Hello everyone. Today I will be presenting our experiment on the LED matrix interface module, specifically the ETMAT 8x8 LED display with the 8085 microprocessor. In this experiment, we display the sequence load MG on the LED matrix. This work is based on the ETMAT model provided by the Excel technology. Let's begin with the introduction. The ETMAT model demonstrates how 64 LEDs arranged in 8x8 grid can be controlled using a microprocessor. Instead of controlling each LED individually, we use input-output ports through the 8255 PPI chip. LED matrix display are widely used in real-world systems such as digital boards, indicators, and display panels. This model includes 64 LEDs arranged in matrix form, port A and port B for control, and A7407 buffer IC, and multiplexing techniques in efficiently drives the LED. Now let's understand the key concept of multiplexing. We have 64 LED, but instead of using 64 control lines, we use only 16 lines, 8 for rows and 8 for columns. In software multiplexing, one column is activated at a time while raw data is sent simultaneously. This switching happens very fast, so our eyes perceive as a continuous display. This is due to pre-resistance of vision. And LED glows only when row is equal to logic 1 and column is logic 0. This is the fundamental principle behind the working of the LED matrix. Now let's look at the hardware connections. Port A of the 8255 is connected to the rows PA0 to PA7 correspond to row 0 to row 7. Port B is connected to the columns PB0 to PB7 correspond to column 0 to 7. This mapping allows to use to control any LED by selecting the correct row and column combination. Experimental setup. Now let's go through the experiment procedure. First, the hardware setup. We connect the ETMAT model to the 8255 port using a 26-pin FRC cable, ensuring proper alignment and power supply. Second, program entry. We write the 8085 assembly program starting at address 2000 H. We set the character count to 6 since we are display 6 characters L, O, R, D, M, and G. Each character is sorted 8 bitmap data with 8 bits per character. Finally, execution. We run the program. The LED matrix continuously display the characters in sequence. 8085 program listing part 1. In this part of the program, the main modification is updating the counter. The value is updating the counter. The value is changed from 03H to 06H so that all 6 characters are displayed instead of 3. 8085 program listing part 2. This slide shows the program flow. The program uses multiple loops to scan columns, display each character, control delay timing, and move to the next character. This loop continues infinitely, creating a continuous display on the LED matrix. Character bitmap data. Here we define the bitmap data for each character. Each character is represented using 8 bits, where each byte corresponds to one column and the matrix. For example, L is formed using a vertical line at bottom row, and 0 O forms a rectangular boundary. R includes a diagonal leg. D has a curved shape. M has a V-shaped center. G includes an inner self. These binary patterns determine which LED glows. This slide shows the visual representation of each character pattern. These are illustrative diagrams showing how LED turn on and off. In the actual system, these patterns are displayed using fast column scanning through multiplexing. Load MG. Experiment. To conclude, in this experiment, we successfully displayed load MG on an 8x8 LED matrix. How multiplexing allows control of 64 LEDs using just 16 lines. How to use the 8255 PPI for interfacing. How to design bitmap data for characters and how per resistance of vision creates a stable display. This experiment helps us understand both hardware interfacing and low-level programming using the 8085 microprocessor. And this is the video for LED matrix.